Hello guys, I hope you are feeling well. I'd like to advise you before see the video of the model answer of the revision sheet for quarter 3 to revise well the basic rule of differentiation. Okay, and how to find the derivative using the chain rule or using the implicit differentiation. Before we solve any problem, I'll remind you by the rule that we will use. Okay, for example, for the first question, find dy by dx for y equal x squared plus 1 all to power 3. As you know, when we have bracket raised to power, it means we have a composite function. Okay, we have a composite function. In this case, we will apply the general power rule. General power rule, which state if we have function raised to power n, to find its derivative, it will be what? N u to power n minus 1 multiply u prime. It means I multiply the power of the bracket by the bracket raised to power decreased by 1, multiply the derivative of what inside the bracket. Okay, as you know, in this case we name it the inner function, and the power, it is called what? The outer function. Now, let's apply the rule dy by dx equal power, just to apply the rule, 3 multiply x squared plus 1 all to power decrease the power by 1, it will be 2. Don't forget to multiply by the derivative what inside the bracket, which is 2x. Then simplify 6x multiply the bracket x squared plus 1 to power 2. That is the derivative of this function. Number 2, I just apply the general power rule. We solve it as we solve the question number 1. Okay, it will be f prime. You can solve before, you can pause the video, then solve and check your answer. But I'd like to tell you all of the model answers of all of the worksheets, the model answer of all of the worksheet, the revision sheet, posted already on LMS. Apply the rule, power, multiply the bracket, decrease by 1. What inside the bracket? The inner function here. Okay, multiply what inside the bracket? 3, which is called inner function, 4x. You can simplify by distribute this one on the inner function. Be careful never and ever to distribute the number on a bracket which raised to power. Okay, I distribute on the bracket which has no, or its power 1. So it will be 9 minus 12x multiply 3x minus 2x squared, all to power 2. Clear or not clear? Now, I'd like to remind you by the natural logarithmic function before we begin to solve question number 3. Before I begin the solution, as you see here, I have to know what are the properties of natural logarithmic function. Len, logarithm of x to power n, it will be n ln x. Okay, this property I will use, this one. What are the benefits of using the properties of natural logarithmic function? Make the differentiation of the natural logarithmic function easier. Okay, what is the derivative of natural logarithmic function? If we take ln of another function u, which we name it the inner function, it will be the derivative. It means d prime, it means d by dx. Prime, it means d by dx. It will be u prime, the derivative of the function that we take ln to it, over u. In this case, let's solve number 3. This one, the natural logarithmic function, I have to rewrite the function to make its derivative easier. It will be what? F prime equal, sorry, before I find the derivative, I have to, I'm so sorry, rewrite the function. Okay, rewrite the function first. It will be yes, equal ln x plus 1 all to power half. Then apply this rule. It will be equal half ln x plus 1. Okay? The derivative of the function f(x) equal the number multiply the derivative of ln, which is here. What is the derivative? Apply the rule. The derivative of the function u here, it will be 1 over u x plus 1. So the derivative, write it in the simplest form, it will be 1 over 2 multiply x plus 1. When we use the properties of natural logarithmic function, make the derivative easier. Okay? I'd like to remind you by another property. I wrote all of the properties of natural logarithmic function already in the revision sheet. Now, ln e to power x, it will be x. Ln and the natural logarithmic function and natural exponential function are inverse to each other. Okay, function. This one cancel each other, so it will be what? X. By the same way, e ln to power x, a natural exponential function, a natural logarithmic function inverse to each other, it will be what? X. I will apply, rewrite this function, it will be what? Ln, here cancel, so it will be what? X square. Why? Rewrite, please, remember. Rewriting function does not mean the derivative. The derivative, I will apply the power rule, it will be 2x. Clear? I hope you understand. Okay, and this revise the basic rule of differentiation, the chain rule, the implicit differentiation. Okay? Now, solve this one, so easy. Chain rule, composite function. I apply the chain rule if we have a composite function. Look here, remember, sec u, the derivative of sec u, it will be, what is the derivative of the outer? Sec u multiply tan u. What? Then multiply the inner function, multiply u prime. So that is u. Don't forget sec or tan, it must has angle. So each derivative, it will be prime, it means d by dx. So sec, but what is the value of u? X to the power 3. Multiply tan, what the value of u? X cube. Then multiply the derivative of u, which is 3x square. Clear or not clear? Now, in this case, how to find the derivative? It's so trivial. By the same way, I know u prime over u. But here, I don't need to rewrite the function because I don't have any property to apply first. The derivative, this is u. U prime, it will be what? 4x with the derivative of 3, 0 over 2x squared plus 3. Clear or not clear? I'll solve number 4, the next part. Thank you for joining. Bye-bye.